In this project, we are going to use data coming from Altos Hornos de Mexico. The variables that we have are operator, work shift turn, group, portion of coke mineral versus iron, temperature of arrival to zone 1, temperature of arrival to zone 2, air feeding speed, high furnace purge time, and phosphorus contamination. Operator, work shift turn, and group are categorical variables. The portion of coke mineral, temperatures, air feed speed, and high furnace purge time, also phosphorus contamination, are numerical continuous variables. They are related because all the independent variables have a different phosphorus contamination number. For example, there are 4 operators, there are 3 work shift turns, there are 4 groups, there are 2 portions of coke mineral, 2 temperatures to arrival to zone 1 and 2 temperatures to arrival to zone 2, 2 air feed speeds, and 2 different high furnace purge times. So the way to obtain the number of the phosphorus contamination depends on all of that variables. They are related in that way. You can have an operator working in a different work shift and in a different group with some portion of coke mineral and working with different temperatures in the 2 different zones with some first air feed speeding, different high furnace purge time, and phosphorus contamination will give different values. Those are the variables that we are using in this project. Our 5 different scientific hypotheses are: the first one is that the operator affects phosphorus contamination. The second, that the portion of coke mineral versus iron affects phosphorus contamination. The third is that the temperature of arrival to each zone, zone 1 and zone 2, affects phosphorus contamination. The fourth one is that the blast furnace purge time affects phosphorus contamination. And the last one, the fifth, is that the air feed speed affects phosphorus contamination. Those are the scientific hypotheses.
We have 7 different statistical hypotheses linked to their respective scientific hypotheses. For the first one, we have that the means of phosphorus contamination of each operator are equal. The H0 would be mu Mario equals mu Isaías equals mu Jorge equals mu Severo, and the H1 would be that at least one of them is different. This statistical hypothesis is linked to the scientific hypothesis that the operator affects phosphorus contamination. The second is that the means of phosphorus contamination of each proportion of coke mineral versus iron is equal. We have that H0 for here is that mu 0.1 equals mu 0.15, and the alternative hypothesis is that mu 0.1 is different than mu 0.15. The scientific hypothesis for this one is that the proportion of coke mineral versus iron affects phosphorus contamination. For the scientific hypothesis that the temperature of arrival to each zone affects phosphorus contamination, we have 2 different statistical hypotheses. The first one is that the means of phosphorus contamination of each temperature of arrival to zone 1 are equal. We have that H0 here would be mu 3000 equals mu 3500, and the H1 would be that mu 3000 is equal to mu 3500. For the next statistical hypothesis would be that the means of phosphorus contamination of each temperature of arrival to zone 2 are equal, and H0 would be mu 2000 equals mu 2500. H1 would be mu 2000 and equal to mu 2500. The next 2 statistical hypotheses are also linked to the same scientific hypothesis. That would be that the blast furnace purge time affects phosphorus contamination. The first statistical hypothesis would be that the means of phosphorus contamination of each blast furnace purge time are equal, and we would have that H0 is that mu2 equals mu4 and H1 would be that mu2 isn't equal to mu4. The next statistical hypothesis would be that the purge time equals to phosphorus contamination mean is greater than the purge time equal 4 with phosphorus contamination. And we would have here that the H0 is mu2 is greater than mu4, and H1 would be that mu2 is less or equal than mu4. The last statistical hypothesis would be that the mean of phosphorus contamination of each air feed speed are equal. The scientific hypothesis would be that air feeding speed affects phosphorus contamination. For H0, we would have that mu120 equals to mu150, and H1 would be that mu120 is different than mu150. For obtaining the distribution that our data has, we perform different goodness of fit tests for different distributions in the software R. And the one that we are basing on our decision mostly is in the log likelihood, which give us that the Weibull distribution has the bigger number, but nevertheless the normal distribution is very close to the Weibull distribution, and the software analyzes that it fits better, comparing it to the other different the goodness of fit tests. So we choose the normal distribution for our data. The parameters that we need to have are the means of each variable of each value that it can take. This is because we chose the normal distribution for our data, and we already have a known variance.
Now we can see the phosphorus contamination distribution of each operator. Here we can see that it has log normal, normal, and Weibull distribution. The proportion of coke mineral gives us a gamma and a Weibull distribution. Purge time gives us beta, gamma, and Weibull distribution. Airspeed gives us normal and Weibull distribution. Temperature of zone 2 gives us normal and Weibull distribution. And temperature of zone 1 gives us a gamma and a Weibull distribution. Now we are going to present you the normal curve plot of all the parameters involved in all the hypotheses. To know which variable is the one that makes more variation in phosphorus contamination, we do an ANOVA, and we found that the temperature of section 2 of zone 2 is the one that makes more variation. The second variable that makes more variation is the temperature of arrival to zone 1. To calculate the Kramer rollover bound, we use the phosphorus contamination mean of 2000 degrees of the temperature arrival zone 2 and the respective of the value 2500. Then we obtained the following curves. The presented curves and the values that we obtained are 3.25 e to the minus 6 and 2.80 e to the minus 6.
For the part of permutation, we decided that it's not applicable for our project because it's not important the order of the factors on our variables. And besides, we already count with a big enough sample size.